All right. The first question I usually ask students, we're going to start with chapter one now. The first question I ask students when we begin the lesson is just, what is statistics? You're taking a statistics class. Can you tell me what statistics means? And there is no one word, guys, that I can explain the meaning of statistics. It's a combination of actions. It's a science of collecting. You collect data, you organize data and graphs, histograms, bar graphs, pie charts, line graphs, etc. And then you analyze and interpret your data. Actually, people collect data not to just to look at it, just to make it look nice, is to get something out of it. So actually, this book will focus mainly on how to interpret data in order to make decisions. So this is the definition of statistics. The first thing that you need to know in statistics is what data means. What is data? When people say data, collect data. It's information that you collect. It could come from observations or from counts, measurements, or responses from surveys. You do a survey and you ask people questions, and the responses that you get are data that you can use later. So this is what the meaning of data is. What you need to know is, guys, is what is a population and what is a sample. Population is the collection of all outcomes, responses, measurements, or count that are of interest. For example, I could say the population of the United States. This is everybody who lives in the United States. Or I could say population is the residents of Michigan. So that includes only all the residents in Michigan. Or a population could be all students at Henry Ford College. And I'm gonna write this as an example. So all students, oops, sorry, right here. At HFCC. So the population includes everybody. Now I want one of you to give me an example of a sample. By definition, the sample is a part of the population. So can you guys give me an example of a sample from the population that I cited above, which is all students at Henry Ford College? What would be a sample?
What about those who are taking this class, Math 141?
That is a subset of the population. It could be the female students at Henry Ford College. It could be biology major students at Henry Ford College, nursing students at Henry Ford College, but the population is all students at Henry Ford College. We defined what data is, guys. It's information. Anything you collect, guys, is data. Anything you collect. Observations means you sit down and observe, just how people are taking action, doing things, and you take notes. Counts is just you count. How many said yes, how many said no, etc. Measurements, you do measure, you just take measurements. And responses, as we said, this is what we get from the survey. Yes, we're recording this. All right, now that's the second definition, guys. So now you know what the difference between population and a sample. Actually, your homework in section 1.1 is just to distinguish between population and a sample, and then probably between parameter and statistics. So let me tell you what a parameter is. A parameter is a number that describes a population attribute. So parameter is a number that represents a population characteristic. And a statistic is a number that describes a sample characteristic. And let me give you examples. First example for parameter is the average age of all people in the United States. If you guys give you this example on a test and I tell you, does it represent a parameter or a statistic? How do you know? Well, I know the answer is parameter, but how did I figure this out? Can you guys type in, or you can
The keyword all.
Exactly. Very good. The keyword is all. And I want to emphasize on this, guys, just all really usually refer to population because it's everybody. So that's the keyword. Statistic. It's a numerical description of a sample characteristic. Example, average age of people from a sample of 3 states. How would you guys know that this is a statistic, not a parameter?
The 3 states.
Yeah, it's a sample of 3 states. It didn't say all states. If it did say all states, then it would have been a parameter. Okay, let's do this exercise together. Decide whether the numerical value describes a population parameter or a sample statistic. A recent survey of a sample of college career centers reported that the average starting salary for petroleum engineering majors is $83,121. Does this value represent a sample statistic or a population parameter?
Is it sample?
How do you know it's a statistic here? Because it says a survey of a sample of college careers. That's it. It's done. It's telling you this came from a sample. So it's impossible for you to make it a parameter because he says it's a sample. Okay. Number 2. I'm not saying number 2, it has to be a parameter. It could have been a statistic too. So let's see. The 2,182 students who accepted admission offers to Northwestern University in 2009 had an average set score of 1,442. What does this value represent? A parameter or a statistic?
A statistic. It's a statistic, isn't it?
Let's see. What other students?
Is it a parameter?
A parameter. Why do you think it is a parameter?
Because it's talking about the students itself, like.
There is a key word,
Or-
guys, here that should help you decide. Indeed, it is a parameter, it's not a statistic, but how do I know?
Is it because of the average?
No. There's another key word, guys. Look at the very beginning.
The students?
The students.
I thought so.
This is the key word, guys. I'll mute all. You can unmute yourself if you want to talk to me, guys. Okay. The 2,180 students. Once you put that there, they're referring to everybody. If this was not there, guys, if I give you this one on an assessment, without this one, I'm saying 2,182. It doesn't mean everybody. It could have been more than 2,182. So this is the key here. It's a parameter. Okay, you will get a chance to do more practice with this when you do your homework online. All right. How to distinguish between descriptive statistics and inferential statistics. Descriptive statistics, guys, involve just describing data. Nothing is said about it. Just describe what you have. And to describe something, guys, you put it in a table, you summarize it, you display it, you put it in a chart, you give an average. This is all description. But when you try to make an inference about something, make a conclusion, prediction in the future, then this is what inferential statistics is about. So you're trying to draw a conclusion about the population. What I'm going to do, guys, I'm going to give you an example, and I'm going to ask you to tell me what the descriptive statistics is and what the inferential statistics is in that example. Watch. Nice example. There you go. Decide which part of the study represents a descriptive statistics and what conclusion might be drawn from the study itself. a large sample of men aged 48 was studied for 18 years. So they follow them for 18 years. For unmarried men, approximately 70% of those men were still alive at age 65. For married men, 90% were alive at age 65. What is the descriptive statistics? The descriptive statistics, guys, is what he says. He says 70% were still alive if they were unmarried at age 65, and 90% were still alive if they were married. So it's this one. This is a descriptive statistics right here. It's nicely done, put in a graph. So that's a descriptive statistics. But what they don't give you guys, they want you to do the inference. What would be a possible inference drawn from the study here? Can someone tell me what kind of inference can you make out of this example?
Marriage impact how long they live.
What is it?
Impact on how long they live.
Okay, what would be the conclusion in few words? Okay, let me see what other students put. Oh, married men tend to live longer. Exactly. Here you go, guys. You can criticize data. But yeah, that's the conclusion that we can make. Now, is this a true conclusion? I don't know, but we need to study that. We need to perform, just some more tests. But according to what we see, it says married men tend to live longer according to the data. Okay. That concludes section 1.1. Section 1.2, guys. It's even easier than this section. We're gonna begin with that one. As I told you, there will be quite a bit of terminologies, and I have a summary of all of them toward the end of this handout. In section 1.2, guys, you'll learn how to distinguish between qualitative data and quantitative data. How to classify data with respect to the 4 levels of measurement. First of all, what is qualitative data? Qualitative, guys, comes from quality. Quality means not a number, it's an attribute. It's a label. It's a non-numerical entry. Non-numerical entry means a number that there's nothing you can do with it. You cannot add it, you cannot subtract it, you cannot multiply it, you cannot divide it. Nothing can be done with it. Your measure is qualitative. Like I'm measuring biology, nursing, business, computer science, place of birth. This is not, this is qualitative. Your eye color, brown, hazel, brown, blue, green, etc. Dark brown, these are all qualitative data. Can you guys help me put a couple more examples in there for qualitative data? You can type it in if you like. What else can you think of as far as qualitative?
How about your race, your office?
Yes, that's one. I'll put it there.
I'm not sure I understand.
What else? Religion, sex, hobby, you name it, guys. What about your social security number? What do you think?
Yeah, only one person can have one.
Yeah, social security number is a label, guys. Although some students would argue and tell me, oh, Mr. Bazzi, you said a number and you said a number is not qualitative. But this number in particular is qualitative because it means nothing. There's nothing I can do with it. Social security. One more example, guys, and then I'll move to the next one. Give me one more. Anything that is an attribute. Attribute means qualitative. Yes, one more.
Hair color?
Hair color, okay.
Told you.
What else did you say? I heard somebody saying something. Skin tone, job, yeah. Here you go, guys. Good job.
Why would it be job? I'm sorry to interrupt.
Well, your job is an engineer, teacher, something like that. Yeah, that's
Oh, okay.
not how much you get paid. It's if when you talk about how much you earn, that's different story. But that's
Okay.
what I was referring. Job name, you know, just a description of a job.
Gotcha. Thank you.
Quantitative data. Numerical measurements or counts. These are actual numbers, guys, that you can crunch, you can add, subtract, multiply. I put some examples there. Age, weight of a letter in pounds or in ounces, temperature in degrees. I need few more from you guys.
Height.
Height,
Your salary.
your salary.
What about your weight?
Weight of a person. What else? Number of students in my class, or number of students present.
How about grades?
It depends. If it is a number,
How about your
yes.
score? Your
Score,
scores.
yes. I agree. That's a better word. So these are examples, guys, of what about your bank account number, guys? What do you think?
No.
No, 'cause
No,
it's-
that is qualitative. So we're gonna put it right here. Although it says number, but it's not an actual number that you can play with. It's just a label. All right. Good. Now, data, guys, can be divided into 4 categories. They call them levels of measurement. Some of them are very weak levels, and some of them are very high levels that we make use of a lot. So I'm going to discuss those 4 levels of measurements and show you how data is categorized. So it is quantitative or qualitative, but it's subcategorized under those level of measurements. The first level of measurements is called nominal level of measurements. This level has only qualitative data in it. Data categorized using names, labels, or qualities, so it's only qualitative. And there are no mathematical computations can be made at this level. Can you give me some examples, guys, of nominal? You already touched on some of them, so all of those would work here, guys. Like color. Can you rank colors, guys? If you wanna rank them, can you do, should we have like a blue comes before red, comes before orange? No, not necessarily. There is no ranking here, so you cannot rank anything at this level. It's all qualitative data. So this is that's why it's not very important to us, because there's nothing we can do with it. Okay, let's go to the next level of measurement. It's a little bit more interesting than this one. Ordinal level of measurements. It's mostly qualitative, but it can be quantitative at times. Data can be arranged in order or ranked. Difference between data entries is not meaningful. So you cannot have 2 values and subtract them. There is no meaning of that. Can you think of something, guys? Can you give me some qualitative data examples where we can rank them?
What about your social class? If you're middle class, rich, or poor?
Okay. That's yeah. If that's your interpretation, yes. What about another one, guys? Your letter grade. Would you agree? A, B, C, D, E. A is the highest ranking, B, C, D, E, etc. So anything, guys, that you place a ranking to it, any qualitative data that you set it up in a way that people, just can have a higher choice or lower choice will become an ordinal level of measurement. Okay, let me give you this example and let's compare the two levels of measurement. Two data sets are shown. Which data set consists of a data at the nominal level and which data set consists of data at the ordinal level? So for the first one, it's top 5 TV programs. American Idol, Wednesday, American Idol Tuesday, Dancing with the Stars, NCIS, and The Mentalist. What do you guys think of this example?
That be ordinal level?
Does everyone agree? Why ordinal? Because he placed the ranking here. If there was no ranking, then I wouldn't be able to do it, I would say it's just nominal. Here, for the second one, network affiliates in Pittsburgh, Pennsylvania. It's just TV stations, just names, not ranked. How do I know they're not ranked? Because he didn't put 1, 2, 3, 4, and he didn't say top 5 or top 4. So that will be what, guys? Nominal. Okay. So these two levels are not really critical for us. What's critical for us is starting in 3 and 4, and more important is 4. Let me tell you what an interval level of measurement, and I'll be happy if one student can give me an example at this level. Interval level of measurement, it's quantitative data, no more qualitative data. Data can be ordered. You can order the data from lowest to largest, largest to lowest. Difference between data entries is meaningful. There is the difference between letter grade A and letter B, B grade is not meaningful, guys. What's A minus B? It doesn't mean anything. Here it means anything. And the 0 at this level, I like you to pay attention to this. The 0 at this level means something. We know the inheritance 0 that we know of means nothing. So if I tell you I have $0 in my wallet, that means I don't have anything. But here the 0 means something. Can you guys give me an example?
How about like a temperature? Like
excellent. Richard. Actually, that's the most common example and the most famous one. Do you guys agree that temperature will suit the definition here? Let me tell you why. We can order temperature from lowest to high, largest, or largest to lowest, no problem. 0 means something. If it is a 0 outside, it doesn't mean that there is no temperature there. It's better than -10 or -20 or -30. So 0 means something. It represents something on the scale. And the difference has a meaning as well, guys, because if the temperature, let's say in Detroit is 70 degrees and in Livonia is 68, the difference is 2 degrees. It does mean side. It has a meaning. So that is an example. Now I saw a students put test score. Test score is not an interval. Let me tell you why. Because if you score a 0, that means you score nothing. If the 0 means nothing, that means it's not an interval. 0 has to mean something here, and it does mean something here. So temperature. Okay, one more example, guys. Can you think of another example? It's difficult to come up with examples at this level, but there is one more. Let me see what we have here. You have to give me a concrete example, something, name something. I have something in mind. I'm going to share it with you. Distance, no. If the distance is 0, means the distance is nothing.
Well, what about a graph? Does a graph work? Like there's negative
what kind
and
of graph?
positive. What is it called?
If you place a 0 in it and a 0 means nothing, your just starting point, that means it won't work.
What about degrees and longitude?
What is it?
what about like measurements for like degrees, like of longitude and latitude, stuff like that?
Yeah, below zero, above zero, yes. If you explain that, yeah, that would work. As long as zero means somewhere. But I'm
Yeah.
gonna give you this example, guys. I don't know if you're gonna be surprised to know that the year 2020. Do you guys, these are called the Gregorian years, and we start using those after Christ. But before Christ, there was time also. It's not like there was no time or we were below zero. We started, just at year 1 or year 0 and start using the Gregorian years. So years is another example of interval measurement. It's a little bit difficult to come up with a lot of examples at this level, guys. So that's why I like it just to pay attention to those two examples. And you might see them, just in the homework. So you know already that temperature is one of them and the second one is year. But here's one question I'm going to ask you. And then we'll do 4 and we'll be done for today. Let me give you this example, guys, and think about it as I propose this. Let's say the temperature, it's winter time. Let's say the temperature in Detroit is 1 degrees Fahrenheit, and in Dearborn, it is 2 degrees Fahrenheit. Can you compare those two numbers by using ratios? For example, does it make sense to say that the temperature in Dearborn is twice as cold or twice as warm as Detroit? Because 2 is twice of 1. Would it? Think about it. 1 degrees Fahrenheit in Detroit, 2 in Dearborn. Or let's say 10 and 5, guys. 10 in Dearborn, 5 in Detroit. 10 is twice as cold or twice as warm as Detroit. Does this comparison make sense?
Yes.
Okay, let me ask you a question since you said yes. If the temperature outside is 2 or 1, would you be able to tell the difference? You wouldn't. Because 2 and 1, it's going to feel very much the same. And 10 degrees, it doesn't mean it's twice as warm. It's still cold comparing to 5. Although it's twice as much, but it doesn't make a lot of difference. Here's another example, guys. If it is in Las Vegas, 80 degrees, and it is 40 degrees in Detroit, does it make sense to say 80 degrees is twice as warm as Detroit? No, that's not true, because you're comparing cold to warm. You cannot do that. So what I'm trying to tell you guys, at the interval level, you cannot compare using ratios and using one being a multiple of the others. That cannot happen. You can do differences, but you cannot say that if I have $10, you have $5, I have twice as much as you. That doesn't work at the interval level. That's what I'm trying to say. This is where it takes us to the ratio level of measurement. That's the last one. That's the most important one. It is similar to the interval level. So data is quantitative. You can do differences. The 0 means nothing at this level, guys. It's nothing. And you can compare data using ratios. So you can say 1 is twice as big or twice as small as another one. That's okay at the ratio level. Can you give me some examples for ratio? So anything probably you can think of, guys, other than temperature and year should work. What would you say? Height? Is it a ratio? Yes. If I say 0 heights means 0 inches, means 0 inches, nothing. If someone is 50 inch and another one is 60, we can say, the 60 is 10 inches more. Or 20 inches and 40 inches, you can say the 40 inches is twice as long as the 20 inches. So it does make sense, just to use ratio. And that's why it's called ratio. Ratio means you can compare using multiplication, guys. Weight. Dollars. If I have $10 and another student has $20, well, the other students can say I have twice as much as you. So that does make sense. $0 means you have nothing. That means the zero is nothing. So the ratio, guys, is the most popular and common level of measurements. It takes care of almost everything other than temperature and year. Number of students. 0 students means no students at all. So this is what the ratio level of measurement. The last example, guys, is to compare these two and tell me which one is interval and which one is ratio. Two data sets are showing which data set consists of the data at the interval level, which data set consists of data at the ratio level. So New York Yankees World Series victories by years. Well, you already know, guys. What do you think years is?
Interval.
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 Yep. And here, home run totals.
Ratio.
If a team has a home run of 50 points and another team has a home run of 100 points, you can say that the 100 is twice as many as the 50. It does make sense. If it doesn't make sense, guys, then it must be an interval. These are the 4 levels of measurement, and let me take you through a summary of those 4, and then we'll wrap this up. Look, guys, all of the data at any level can be categorized as qualitative or quantitative. That's why I put yes, 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 yes for all of them. At nominal, you cannot arrange data in order. You cannot subtract, doesn't have any meaning. You cannot determine if one value is a multiple of other, has no meaning, no. Ordinal, data is qualitative or quantitative, yes. Arrange data in order, yes, but you cannot subtract data entries, doesn't have any meaning. Interval, quantitative data, yes. Arrange data in order, yes. Subtract, yes, but you cannot say that one temperature is a multiple of another temperature. That doesn't work here. Ratio, look at the ratio. That's why I told you it overrides all of them. It's the most important, just level of measurement. It's all yeses right here. So with this one, guys, we'll end our discussion of the lesson today. And we will meet again tomorrow. We'll finish section 1.3 and start chapter 2. And you'll receive some email from me today, just as the wrap up of what we did.